Hi, welcome to Nomis Academy. In today's video, we are looking at integration. Alright, integration is the reverse process of differentiation. In my previous video, we looked at differentiation and the application of differentiation. So today, we are going to look at integration as a topic, and under it we have antiderivative. I'm going to explain the meaning of antiderivative. Alright, just like I said, integration is the reverse process, the reverse form of differentiation. Now, whenever you have a function like this, let y be a function of x. Okay? And then dy over dx is equal to f prime over x. Now we call this antiderivative. Why this is called the derivative. Okay, let's pick an example to make it more clearer. We have a function y equal to x squared. This is the function given, x squared. Now the derivative of this function, the y over the x, is equal to 2x. Okay, this is the derivative of the function. Now the antiderivative of the function, derivative of x squared will be what? Is equal to x 2 plus 1 over 2 plus 1, which is something as x raised to the power of 3 all over 3. So you can see we have a function. The derivative of the function is 2x, and then the antiderivative of the function is x cubed all over 3. Now, in general, we can write the antiderivative of the polynomial function as, in general, the antiderivative of xn, which is a polynomial function, is given as xn plus 1 all over n plus 1, where n not equal to minus 1. Okay? So, this is the general form of writing the antiderivative of a polynomial function. Alright, now let me explain this again. This is the function, this is the derivative of the function, and then this is the antiderivative of the function. Now let's talk about the arbitrary constants. The arbitrary constants. Alright, supposing you have y which is equal to x squared over 2. Okay, we have this, and then the y over the x of this function is x. The y dx of the function is x. So the antiderivative, this is actually the antiderivative of the function. Now, this antiderivative, y equal to x squared all over 2, is called a solution, or a particular solution. Let's use a more detailed example. We have y equal to x cubed over 3 plus 5. Okay, we have this. Now, we say that the y over the x of the function will be x squared. X squared is the y, the x. Meanwhile, y equal to x cubed over 3 plus 5 is the antiderivative of this. Now, we call this a particular solution of the function. This x cubed over 3 plus 5 is called the particular solution, called particular solution. So when we now have the antiderivative to be y equal to x cubed over 3 plus c, okay, the derivative is also x squared. The derivative is also x squared. So, but here we are having c. So we call this a general solution. So y equal to x cubed over 3 plus c is called a general solution. General solution. Meanwhile, c is called the arbitrary constants. Alright, so whenever you solve, it is expected, in as much as what you have is a definite integral, it is expected to slot in your arbitrary constant. So, but when you are asked to find a particular solution, then that constant must have a real number. Alright, so now in general, the arbitrary constant or the general solution of a function or the antiderivative of a general function is given as, we have it to be, when we have our function, let's use the integral sign, xn dx, then we will have xn plus 1 all over n plus 1 plus c. This is the general form, and this is the basic or the foundation of integration. So whenever you're given a problem to integrate, you express the function in this form and then proceed further to follow the principle stated. Thank you for watching. See you next time. Bye.